let us see how a curved surface of a film creates a pressure difference. So, let us consider a surface, curved surface like this, which has, so this is the curved surface. So, let A, B, C, D be a curved surface, and let this side be x and this side be y, represented by y. So, you see this curved surface has its radius of curvature, suppose at say r1. So, this is r1, this is r1, and this is the radius of curvature for this surface. This is called principal curvature of radii. Now, you see this film is dividing these two portions, and the concave side will have always the more pressure than this convex side. So, this side will have more pressure in this side, so as to balance the surface tension force. So, let us see that how much will be the pressure difference and how it will be the function of R1 and R2. So, consider a curved surface of length x and y with principal curvature of radii as R1 and R2. R1 is shown in figure, R2 will be R2 this radius of curvature, and R2 will be like this, suppose. R2 is not shown, suppose. So, here now the concave side will have an excess pressure over the convex side. So, this excess pressure is created by surface tension. So, let us calculate this. Let there be a small increment along z direction, that is the normal direction to the surface. Let there be a small increment along z direction, which is normal to the curved surface. So, you see here what happens, A rises to A dash, B rises to B dash, and you can see C rises to some C dash and D also. So, we will have this new surface as this much. This is D dash, C dash. So, you can see this. Thus ABCD surface changes to A dash, B dash, C dash, D dash. So, let us imagine the small increment in internal pressure has shifted this surface slightly upward. So, let a virtual increase in the pressure at the concave side let a virtual increase in the pressure of the concave side has changed the surface from ABCD to A dash, B dash, C dash, D dash. So, we are going to use the idea that the surface tension is equal to the change in the free energy per unit area. So, if surface tension is there, so let us calculate the change in the area, the free energy. So, we can talk about surface tension. So, area, initially area was xy and delta area now becomes x plus dx into y plus dy minus xy. This is again xy plus dxy plus y dx plus dx into dy minus xy. So, xy cancel. I neglect the product of two differentials, which gives me that the change in area is x dx x, this is dx into y plus y into dx, that is x into dy, sorry, dx into y, let us write y here, and then dx y into dx and then x into dy. So, x into dy. So, that is x dy plus y dx. This is what the area has changed. So, the work done in increasing this area, so the work done in increasing the area is given by, so you see here work done is given by the unbalanced force, that is P. Suppose this pressure here is excess, work done in increasing the area is given by P, where P is the excess pressure denoted. So, I denote P by excess pressure into D volume is equal to work done, implies this excess pressure volume means dz. Suppose in this direction it has increased by dz distance. So, P into dz is equal to the work done, that work done is equal to surface tension into area. So, that is implies this P into dz is equal to S dA. S and dA means x dy plus y dx. And you see dz. So, now which implies further that P is equal to S times dz by x dy plus y dx. So, this is P, where P is the excess pressure. So, now we got my formula for excess pressure, which we have to calculate, S times x dy by dz plus y times dx by dz. Let us write this as 1. So, now you can see these two triangles here. Here we have two triangles A C1B and A dash B1 C1. So, just I am drawing this as a straight triangles. These are curved triangles, C1 B dash A dash, and this is how much this is AB. This is x, this is our x plus dx, and this is dz. So now let us use the similar triangles. This is R1 and this is R1, means from B to C1 and A to C1. So we have x by R1, we have x by R1, this by R1 is equal to x plus dx by R1 plus dz. So I want my dx by dz expression. So you see x R1 plus x dz is equal to R1x plus R1 dx. So I want dx here, dx by dz. So this R1x cancels out. So we have dx by dz as x by R1. So this is 2 point. Similarly, we have here also these triangles which I have not shown and now I am showing here. This is B dash C dash, suppose B dash C dash, and you see here this is C2, the point C2, and this was BC. This was equal to y R2 and this is R2 and this is dz. Suppose it has changed by dz amount. So here you can see this is y plus dy. So what we will write, y by R2 is equal to y plus dy by R2 plus dz. Now cross multiply, y R2 plus y dz is equal to y R2 plus R2 dy. We have y R2 cancel. So we have here dy by dz is y by R2. So this is point number 3. Now we will substitute this here. So we get P is equal to x by dy by dz is y by R2. dy by dz is y by R2. So x y by R2 plus here dz is also there, this dz. So now plus this y is here, dx by dz x by R1. So xy by R1 will be not there. Excess pressure into area, this is area, excess pressure into area. So the work done is excess pressure into area dA. So now this is dA, this is small mistake, dA. So now you see here xy is we should not write dA, we should in fact write area, not dA, it is actually area. So area. So here you see this area xy cancels, and so we have P is equal to S into 1 by R1 plus 1 by R2. So we have thus derived the result for excess pressure, which is equal to S, the surface tension, times 1 by R1 plus 1 by R2, where R1 and R2 are the principal curvature of radii of the surface. So now for a spherical surface, R1 is equal to R2 is equal to R. So we have excess pressure will be equal to Sy 1 by R plus 1 by R is equal to 2S by R. So thus the excess pressure for a spherical surface has an expression 2S by R. Now for a cylindrical surface, so you see here a cylinder surface is made when you translate a a line along a curve. So, it is one radii is R1 and another radii R2 is infinity. So, R1 is equal to R and R2 is equal to infinity. So, we have excess pressure formula 1 by R1 plus 1 by R2 implies excess pressure formula becomes S 1 by R1 plus 1 by infinity, that is 0. So, excess pressure formula is S by R for cylinder.